the table of contents. First, we'll be going through the introduction, then the history of photography, how does the camera work, what steps are involved in developing pictures, the science behind photography, the actual lab, film developing information, photo information, conclusion, glossary, and references. Enjoy the show.
Hello America, I'm your host Mohanna Aziz and welcome to the Mohanna Show. Today I will be giving you a very important lesson on the history of photography. You will learn how to work a 35mm camera, develop your own black and white film, learn the chemistry behind photography, and meet the scientists who started it all. Stay tuned for this very important episode.
Mohanna Show was brought to you by Wikipedia, where learning is fun.
Hey guys, welcome back to the Mohanna Show. Now, as I promised, first we will start with meeting the scientists from the past. So let's take a look at the big screen.
I present to you the scientists from the past. And our first scientist is... the past. Okay, so the first scientist that we will be discussing is Sir John F. W. Herschel in 1839. He was known as the inventor of photography. He has made many improvements to the photography process. Very important guy. He discovered, the platinum process. It's a basic of light sensitivity of a platinum salt. Very nice. He also experimented with color reproduction rays of different parts of the spectrum. So the next scientist to compare their own color to the photography paper. He discovered sodium thiosulfite to be solvent of silver hydrolynes in 1819. The next scientist that we will be discussing is Louis Daguerre. He was known as one of the fathers of photography. He invented the daguerreotype process of photography, which is the first commercially successful photography process, directed by a positive made in camera on a silver coppered plate. The plates were called Sheffield plates. It was produced by heating or rolling silver foil in contact with a copper plate. The image was made on the surface. It was very fragile and could be rubbed off with just a finger. When the plate was finished, it had to be angled so it can reflect a dark surface in order to view the image. Okay, so the next scientist is Henry Tillblat. He invented the calotype process. The calotype process is the use of paper coated with silver iodine. He worked on photomechanical reproduction, which led to a creative engraving process, which was called the photograver. The photograver was a photomechanical process by a copper plate is coated with the light sensitivity, which had to be exposed to a positive film. Okay, so our last scientist is Joseph Niepce. He invented the helographic process. It was a technique used to produce the world's first known photography in 1825. Helographic is a photography process used to make the permanent photography for nature. He used a punnetman, which is a sticky black or highly vigorous liquid. He would coat it to the glass or metal so it would harden in relation to expose the light. Then he will wash the plate with the oil, and then the hardened image will remain. The Mohanna Show is brought to you by Google. Section 3. How the camera works. Okay. So the three important parts are the lens, the film, and the camera. The lens. The lens has an important job to do. The job is to redirect the light from the object back to the camera to form the image. When you first take the picture, the light enters through the glass and bends when it first enters and when it exits. And as it exits and enters, it forms different angles. The lens focuses on the ray of light, which points behind the focal point, creating a real image. The light hitting the film is a chemical reaction. It is exposing the film. The shutter closes and the exposed film goes along the rail. And then it repeats with the unexposed piece of film to take another pictures. Okay, how the photos are created. Photographs were made on a large, individually copper-sewn glass plates. Each plate had to be coated with a light sensitivity embellished called silver hydrolynes. This had to be done before exposure and developed. When the light hits or strikes the film, it causes the chemical structure to change the particles. This creates a selective image. The black and white film only has one layer of embellish. All light reaching it is reproduced as black and white or shades of gray. After processing, the image or picture is recorded on a black and white film, which is the negative. Then it will be printed onto a light-sensitive paper, which produces a positive image, which is the photograph. The Mohanna Show is brought to you by the Encyclopedia. Section 4. There are many chemicals used to make the black and white film. The chemicals we used are developer, stop bath, fixer, perna wash, and photoflow. In this section, I will explain the importance of why we use all of these chemicals in there to make an image appear on a film. It also acts like a base. The development process is a reduction process. The developer changes the latex image. It helps make your picture visible. The developer reduces the silver hide lines to just silver. The developer process, we use a developer process because oxidation, so it remains constant throughout the whole process. Sodium sulfite is used as a preservation for developing agent. This keeps from the developing process from oxidizing and allowing to stay constant throughout the developing time. When a lot of sodium sulfite is used or added, it raises the pH level and acts as an alternator. The higher the pH, the faster the development occurs, and when this happens, the grain size gets larger. So the lower the pH, the smaller the grain, which is the silver hide lines. Sodium carbonate is the most commonly found in alkaline developers. In the developers we used, which is Kodak Professional D-76, has a Bronox in it and has a fine grain developer with a pH of 9.5. Metalloid developers very quickly, and hydrocarbon develops very slowly, but when they combine together, they act very fast and develops a very high concentration. The stop bath. The stop bath is a neutralizer. It neutralizes the developer. The stop bath is considered a weak acid and is also a base. By using the stop bath, it helps slows down the process, which gives you more control. The stop bath is basically like a water. It doesn't harm your film. By using the stop bath, it makes your negative less grainy and clearer too. The stop bath also helps neutralize your pH levels, because when you are doing the development process, your pH levels are very high. The stop bath helps prevent the gas bubbles in the illusion from coming on your film. The stop bath also prevents the fixer from running out too fast and allows more negative to process. Next is the fixer. The fixer hardens the illusion on the film. The fixer removes the unexpected silver highline grains or crystals that are left over from the film's illusion. The fixer fixes the film so that it's no longer light sensitivity. It also leaves the metallic silver intact. The fixer also leaves behind stains on the film. The perna wash, it washes illusion from the film. The perna wash removes the silver highlights and makes your negative permanent. The photoflow prevents streaking on the film left behind by the fixer. Temperature, time, and contamination. The importance of keeping the temperature at 21 degrees Celsius is to make sure the chemicals don't damage your film. It is very important that the film is neither too hot or too cold. If the chemicals are too hot, they will work faster and can cause lower contrast. If the chemicals are too cold, they will work slow. Time is very important because you have to make sure that the chemicals are in long enough so you can develop your film properly. If the chemicals are too short, it could cause to be in underdeveloped film, and if it's left in too long, it can cause your film to be overdeveloped. It is also very important you make sure you wash all your materials used to develop your film. Make sure you wash your thermometers off from measuring the degrees of your chemicals, and make sure you don't mix them up. Results of contamination: destroying your film, lower contrast, and makes poor results. Guys, okay. So I know you guys have been waiting quite a while for me to reveal what is the science behind photography. Well, it's a lot of chemicals and equations involved into developing the film and in the camera itself, well, the film. So I put together a PowerPoint for you guys to show you all the chemicals involved, and I gave explanations and everything for you to understand the chemistry behind the photography. So I hope you guys will understand it and enjoy it. So if you look back to the big screen, once again, here's the chemistry behind photography. Okay, the chemistry behind photography. Silver bromine is in the film developer and the stop bath. Silver bromine is a soft, pale yellow, water-insoluble salt known as silver hydroxides. In the black and white film, there are silver hydroxides. Silver bromine is prepared by reaction of the silver nitride with alkali bromide and potassium bromide. And there's the chemical equation when it reacts with each other. In the development process, silver metal atoms are formed. This is called elective image. Okay, and AGX reduce when the developer is involved, which reduces black silver metals in the area to expose light. The develop process is stopped when using a stop bath. The stop bath contains an acetic acid, and that's the equation right there. Well, the chemical symbol. An acetic acid is a pure acid, a colorless, vigorous liquid, or a glassy solid. Silver hydroxides are removed with the fixer. When you are fixing the image, you are making the image permanent, causing it to be exposed silver X on the photography film. The fixer contains disulfate ion, C2O3. Then a soluble silver is formed, AgBr plus 2s2O3, which forms a silver in parentheses S2O3 close parentheses 2 plus Br. After the development process, the film is now fixed. What remains are the silver salts and are removed to prevent further reproduction. By removing the silver salts, it leaves the negative film, and then the photoflow is used in the sodium disulfide and reacts. And that's the chemical equation right there when it reacts. Okay. The Mohanna Show is brought to you by Google. Okay, to get a better understanding of how to develop the film, I actually did the lab myself. So here, if you look back to the big screen, you will find my findings and how the objective of the lab and the procedure, the observation, and my conclusion. So look right to the big screen, and we'll be right back. Developing your black and white film, section 6. The procedure. Okay, I summarized the procedure for you to give you the overall importance and point of view for this. Okay, so first we had to put the film into the tank the day before. We had to get a black bag, which looks like a t-shirt, and it has 2 zippers. You open the first 2 zippers, and then inside you'll put the film opener, the scissors, the film tank, and the reel. Once everything was in the bag, we zipped it up, both zippers. Then you put your hands into the openings on the 2 sides, and then you would feel with your fingers, and you can't see nothing at all, so you're feeling with your fingers. So first you cut the part of the film off and begin to open the film. And you'll begin to load the film into the reel. After that, we would cut the end of the film. The next day we began developing the film. We got all the chemicals needed to the film, such as the developer, stop bath, fixer, pernouage, and the photoflow. Next, we got out 4 beakers and filled each beaker to 600 millimeters and labeled our chemicals. That's very important to make sure you label your chemicals because they all look pretty much the same. They're all clear. Then we put the thermometer to keep track of the temperature, which all the temperature had to be on 21 degrees Celsius. Then we got a hot plate and 2 aluminum pans, and one we put ice in, and the other aluminum pan we put on the hot plate so the beakers keep the beakers from breaking. Then we began putting our chemicals into the tank. We put the chemicals in this order: first the developer, stop bath, fixer, pernouage, and photoflow. Once we put the chemicals in, we followed the directions for agitating and resting. Once we finished the chemicals, we were directed to wash our films 30 times with water. And no cutting it short. We had to wash it 30